the factoring parabola connection. So don't get too confused, you're in the right spot. I know this guy here is not a hamster, it's a squirrel, but don't be too alarmed. Our objectives for this lesson are going to be how are factoring quadratics and graphing parabolas connected, and 2, how do I apply the zero product property? So the zero product property tells us that when we have two terms, so let's say a times b equal to 0, that means at least a or b or both have to be 0, right? Because any number times 0 gives us 0. So if we look at a, let's say a is equal to 0 times b is any number. I'm going to say 5. 0 times 5 gives us 0. And vice versa, let's say a is 7 times, if b is 0, that also gives us 0. And then the third scenario that it's talking about is when you have a times b, there is a possibility that both of these terms can be 0, right? 0 times 0 is still 0. For our prereq skills, finding a y-intercept, that's when we let the x values equal to 0, right? You plug in 0 for x and you find the y-intercept. And then finding the x-intercept, you plug in 0 for y, which is what we're going to be doing, where we're going to be applying the zero product property to, right? So we got a question mark there. We're going to find out how to do this. So example 1, find the x-intercepts of parabola y equals x squared plus 7x minus 30 using the zero product property. So the first thing we want to do is we want to get our a and b. Okay, so we want to start off with factoring our quadratic here. All right, so we have y equals x squared plus 7x minus 30. Okay, we're going to use the diamond method here. So remember the multiple ways that we can factor. For now, diamond makes most sense for this one. Negative 30, 7. Okay, so now what multiplies up to negative 30 and adds to 7? It looks like it's going to be 10 and 3. Now I got to figure out which one of these is negative. Since this is a positive 7, my 10 has to be positive, right? Because 10 is the larger number. We want more positives. So that's going to be a negative 3. So now we're going to rewrite our quadratic. We have x plus 10 times x minus 3. Now here's where we're going to apply the zero product property. We're going to set this equal to 0. So consider this a and consider this b. Okay, so either one of these has to be 0 or both of them are 0. So what we're going to do is we're going to rewrite these separately because we want to find these zeros. So I'm going to take x plus 10 and I'm going to set it equal to 0. Then I'm going to take x minus 3 and set it equal to 0. Now I want to solve. So x plus 10 equals 0, we subtract 10 from both sides, and we get that x equals negative 10. I'm going to box that up. And now on the right hand side, we got x minus 3 equals 0. I'm going to add 3 to both sides, and we get that x equals 3. Okay. So now these are the two zeros of our quadratic, and if we look, we kind of have to determine what the zeros give us. So if we're looking at this graph here, right, so this is the graph of y equals x squared plus 7x minus 30. So if we're looking at that graph, we're looking at what it gives us. We got negative 10 here on the left side, and it turns out that one of the x-intercepts here are negative 10. For the other one, we got 3, and it turns out that the other x-intercept that we have there is 3. Okay, so what we need to take away from the zero product property is when we factor our quadratic, we get our parentheses, we set them equal to 0, and we solve. So we got x equals negative 10 and x equals 3. That gives us the x-intercepts of the parabolas that we're working with, right? So that's an x-intercept, and that's an x-intercept. right? And it's evidenced here by the graph. And that's it. Let's go example 2. So remember that we're still using factoring. We got y equals 2x squared minus x minus 10. So in this situation here, a is not 1. So we have to start with multiplying a times c. So we're going to rewrite this as x squared minus 10 minus x. And now 2 times negative 10 gives me a negative 20. So now I go to doing my diamond. What multiplies up to negative 20 and adds to negative 1. So I'm looking for those two numbers. It's going to be 5 and 4, and we got to figure out which one of these is going to be negative. The bottom's negative, so the larger number has to be negative. So negative 5 and 4. Just to confirm, negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So now I can write my two terms. I'll have x minus 5 times x plus 4. Okay. Now we're not done here because remember that we multiplied by 2 up here, and we have to undo that multiplying by 2. And we do that in this step. So we divide by 2 and divide by 2. Okay. So remember the steps for this problem here. If you can reduce it, you reduce it, or if it divides evenly, you divide it evenly. So this doesn't reduce, the 2 gets shot out in front. So this will turn into 2x minus 5 in a parenthesis. And on the right, 4 divided by 2, that divides evenly, so this turns into x plus 2. Now we're going to do our zero product property. We're going to set it equal to 0, and each of these are going to get set equal to 0 individually. So we have 2x minus 5 equals 0, and we have x plus 2 equals 0. Now we just simplify, add 5, we get 2x equals 5, divide by 2, and we get that x equals 5 divided by 2, use your calculator, you get 2.5. I'm going to box that up. Now on the right side, I had x plus 2 equals 0, subtract 2, you get x equals negative 2. And box that up. So again, that graph is there for you to confirm your answer, right? Because this tells us an x-intercept, and this tells us an x-intercept, x-intercept. So negative 2 is one of our x-intercepts, and 2.5 is one of our x-intercepts. Okay, now this one here, we need to find the x-intercepts of y equals 4x squared minus 25. Okay, so a lot of factoring practices coming into these. So now this one here, I noticed that I have two terms, and if I have two terms, chances are we're going to be using a difference of 2 squares. I want to check and see if these are all perfect squares. 4 is a perfect square, right? That's 2 squared. 25 is a perfect square. That's 5 squared. So I do have perfect squares, and x is already a perfect square. It's x squared. So I can rewrite this as 2x squared minus 5 squared. All right, so I have a perfect square on the left side, and I have a perfect square on the right side. I still have the same values, right, because that 2 gets distributed into both, so that's 2 squared x squared, that's 4x squared, and I have negative 25 on the right side. Okay, so if I have a difference of 2 squares, I know that my factors are going to be 2x plus 5 and 2x minus 5. Okay, so that plus 5 and that minus 5, remember that gets rid of that middle x term, right? That b term is not there, so it gets rid of that term. That's why this doesn't have 3 terms. Okay, so zero product property rule, set it equal to 0. I'm going to pull this off to the right here. So I have 2x plus 5 equals 0, and we have 2x minus 5 equal to 0. If we simplify, subtract 5, you get 2x equals negative 5. And then you divide by 2, and you get that x equals negative 2.5. I'm going to box my answer. And it looks like we're doing it right so far. One of the x-intercepts is negative 2.5. And on the right side, same steps, add 5. So 2x equals 5. Divide by 2, and you get that x equals a positive 2.5, which is right there. So we have both of our x-intercepts there.